All right, here we go. Week 1, day 2. Today we are going to be doing a graphing review. Just a review over how to put in your transformations and put those into your table and make changes and do all that kind of stuff. Hopefully, this video is going to be a lot shorter than the last one. I had a lot of information to get in at the beginning. Just a lot of reminder, background info, bring some stuff back in. So hopefully today is a lot quicker. And in the future, hopefully our lessons are a lot quicker. So here we go. Quick review, vertex form. Now when I talk about vertex form, I am talking about for quadratics. Okay, so quick review, that vertex form is this right here. Y equals a times x opposite of h squared plus k. All right, just a reminder of some of these things here. A, that is your vertical stretch, your vertical compression, and your reflection. Also, just a reminder that Big Ideas does not use the word compression. They use the word vertical shrink. Okay. Reminder that this right here, H on the inside, is your horizontal movement, so your left and your right. Okay. K is your vertical movement, so your lower to your upper. And each of those affects the graph some way, somehow. Vertex, remember you get the vertex from your horizontal movement and your vertical movement. So that is why we say that the vertex is HK. And remember your axis of symmetry. Remember what a quadratic looks like? Okay, so it makes that curved shape. So a quadratic has this curved shape. Okay, and that quadratic, actually right down the middle, if you were to cut it, it actually is the same on the left side as it is on the right side. Okay, so that is why we have an axis of symmetry, which is this invisible line going right through here. Now, big things, axis of symmetry is an x equals, okay? It is a line. X equals, and if it has to go right through the center, that means it has to go right through the vertex, which means the x value of the vertex is your h value. One quick thing, I do know one of your practice assignments is going to ask you about this. When does a quadratic have a maximum versus a minimum? Okay. Remember, a maximum is a high point, while a minimum, realize that that's right on my face now that I see it here, guys. A minimum is a low point. Okay, so a minimum. Okay, so here we go, doing a little bit of graphing. So graphing absolute value equation. So I know I just talked about quadratic, and here we are graphing absolute value. Okay, this is just a friendly reminder that the parent chart for the absolute value, okay? Remember, I want to try to go somewhere towards the center of my graph and somewhere towards the center here, okay, of this graph, x and y value of y. So that's why I'm going to choose these values right here. Okay, when I choose those values, this f of x means I'm taking the absolute value. Well, if I take the absolute value of -2, it is 2. If I take the absolute value of -1, of 0, of 1, and of 2, I'm taking the absolute value of those numbers. Okay, now on my graph, remember when I go and graph this, and I might be able to move this upwards so you're not right on my face. Let me see. Oh, never mind. Let me see if I can move my face upwards here. I can, maybe. Just kidding. I don't know where my face went, guys. Okay, I was able to move my face around on the screen there. So when I put my ordered pairs in, I have the -2 and the 2, the -1 and 1, 0, 0, 1, 1, 2, 2. Remember, absolute values have straight sides because the outsides on an absolute value are constant. Okay. Domain and range, remember, as it works its way to the left side here, what's happening? Well, yeah, it's going up, but as it's moving upwards here, what's going to keep happening? Well, it's going to keep moving left. So that's why I'm going to say, hey, it's approaching -infinity. Same thing on this right side over here, that as it's moving upwards and it keeps going up, well, then it's still going to keep going right based off of that arrow. So that's why I say it's going to approach infinity. Okay. Now, range, remember right here, at this vertex, because this also has a vertex, there's nothing happening down there below. So that's why we say, hey, this is starting at 0. And where's it going? Well, both sides are going upwards. Okay? So it's going to continue all the way to infinity. Now remember a few things here from the last lesson, that negative infinity to infinity is all real numbers. You will see that. Anything that's greater than or equal to 0, okay, for y, is another way that you can write that range. Quadratics, something similar here. If I start with the center of my graph, okay, and I go, okay, I'm going to square my terms. We'll square it. And that's what I get from my y values, okay? So just a reminder of how to graph a quadratic. I put my 0, 0 on there first. I have 1, 1, I have 2, 4 going up here. Negative 1, 1, and negative 2, 4 here. Remember, a quadratic is a curved shape. It is not going to be straight on each side. Mine kind of comes to a point a little bit down there, but remember, it's curved. Domain and range, very similar here for quadratics, so I'm not going to talk about it right this minute. We will talk about it on our examples, though. Okay, so here we go. Graphing a quadratic function. So it tells me here, graphing a quadratic, what gives it away? Two things, that and hey, it says the word quadratic right here. Okay, so when I'm graphing a quadratic, I do know that I'm starting here. So I'm going to put some of the things I know down first. Okay, then I'm going to go through and I'm going to list my transformations here. Well, what's happening? Well, on my graph, when I start here with this negative sign, well, what does that negative sign mean? Well, that negative means, hey, there's going to be a reflection. What does that automatically mean? That means instead of my quadratic opening upwards, I now know that it's opening down, right? When I look here, it says, hey, I have a +2 in here. Well, remember, inside is opposite. So +2 actually means instead of moving to the right, I'm actually going to move 2 to the left. Okay, so I am moving left 2 units. Okay, then finally I have this last part here. We'll use yellow. +4. Okay, well, +4 is on the outside, so it means I'm taking my graph and I'm moving it up 4 units. Now, if I use those transformations to make changes to my graph, remember that I must do something that is out front to multiply first. And I'm multiplying by a -1 before I move that graph to vertically move it upwards. Okay? On the x values, I am moving it to the left 2 units. So remember, moving it left 2 means, hey, I'm going to -2. Now, however you want to show your -2, whatever you're used to, I put it out front, and sometimes I do -2 plus. If you are used to doing it where you come over here and you say, hey, I'm going to -2, whatever you are used to from however you did it from trimester 1. Okay? But I know I'm subtracting 2 over here. So go ahead and do those to your table. Alright, so that is what your table should look like after you subtract 2 on the x values and after you reflect and move up 4 for the y values. Okay, before I graph this, I'm going to go ahead and name some things. I'm going to go ahead and name the vertex. Well, the vertex, okay, right here, it's moving left 2 and up 4. Okay, so I know the vertex should be sitting at -2, 4. Okay, axis of symmetry, I know has to go straight through that vertex. Remember, it is x equals, and I'm going to say -2. What I want you to do is go ahead and graph this on the graph now, if you have not already, and I want you to state the domain and the range, please. Alright, go ahead and check your graph with my graph here. Also, you can check your domain and your range. Also, let me move this up a little bit so maybe you can see a little better. Maybe. There we go. Okay, so check your domain and check your range. Remember domain, all real numbers, we've talked about that. Range, you may also see this as y is less than or equal to 4. Okay, so now that I've kind of given you one example, what I want you to do is on each of these next two, I want you to pause the video and do the same thing. So this next one happens to be an absolute value. So I want you to do the same thing here for this absolute value function. Pause the video, do the example, then unpause and you may check. And then you're going to do the same thing with the third example. Alright, give yourself a check here on this one. I did cross off the axis of symmetry because we don't really talk about that with absolute values, but there is still a vertex with absolute values, so I went ahead and listed that, and it's still in the same place. The only thing to notice here is that the range, remember, another way to write it is y is greater than or equal to 0. Some key things to check if you got it wrong is maybe checking to make sure you started with the absolute value table of -2, 2, -1, 1. Rather than the quadratic table. Okay, so here is the next example. I want you to do the same thing, write it down, and I want you to write everything, including the range here, and unpause it and check your answer. Alright, give yourself a check there. A couple things to notice. Make sure you did use the quadratic table to start out with. And also when you were making changes, make sure that you did do the multiplication before you did the subtraction over here on the y's. That is one of the biggest mistakes that can be made. Also, things to note, axis of symmetry is x equals. Another way to write that range is y is greater than or equal to -2. Alright, thanks guys.